Students will discuss about 2.6.6 packet tracer, verify single area OSPF v2. Okay, so this one we'll do now. We have 1, 2, 3 routers. Okay, there is another network with R4, S4, access point, laptop is branch office, not connected. We'll connect this later. What's the purpose of this activity? So before we connect the this branch office LAN, no, we want to verify the configuration. I already discussed like OSPF is configured between R1, R2, R3. There will be router ID for each router. Okay, there are serial connections, network, LAN connections there. There is ISP network is there. Okay, they are all already set. Okay, they already have neighbor adjacency everything. Before we add R4 to this S3 or R3, we need to verify all details in R2, R1. That's what we have to do. Okay, so verify part one, verify the existing OSPF v2 network with using these commands. Okay, so start with step one. So here uh, we have some routers. So these routers will have been configured as which one enterprise routers, or they have been given some passwords. Okay, R1, R2 are given some username password. So security purpose, branch admin username, password branch 1, 2, 3. Okay, let's start with R1. So R1, open R1, go to CLI. Okay, the username is they mentioned here branch admin. Let me try the copy paste working. Otherwise, I'll go for typing. Sometimes I also replace it. Okay. Okay. So I'll go for branch admin. Okay. Then password they mentioned here. Same here. Okay. Branch 1, 2, 3, 4. So I'll put here branch 1, 2, 3, 4. Okay. Now what they're asking, execute show IP route. So to display the routing information, no show IP route. Okay. So here there are so many routes are there. They're asking how did router R1 receive default route. Okay. So this, this C are direct connections. O means OSPF connection. This is default route. Okay. So this one via 172.16.3.2. Okay, I got a default route via 172.16.3.2. Then what is that O star E2? That means you remember today we did the on default route in one router, say R1. Then R1 want to send broadcast this route into other routers. Default route should be sent to other routers. Now for that we what we use default information originate command, right? Remember that default information originate command. So the answer for this question is it is a default route learned via OSPF. Okay, it's a default route learned via OSPF because today in the lab we discussed no, you make a default route like 000 any network any mask 00 through some exit interface or next to a pike, IP, right? So that I will transfer, I will forward to other router broadcast via default information originate. So that is used for which one? OSPF. By OSPF we can forward the default. That's the answer for that. Okay. So answer for this question. There is a question. How did it receive the default route? It will be via default OSPF. The route learned via default route learned via OSPF. That's why it is OSPF. Then E2 000. That's okay, this one. Okay. So I'll do one thing. I'll add this answer in a Word file. So it's easy for you to the Word file. Okay, let me time. Okay, in Word file, I'll open this one and I will type the answer here. Okay, later you can refer on videos. I will say, so I didn't hear that answer, so I'll just type in the answer here. Okay, just wait a few seconds to open the Word. My laptop is a bit slow now, it's getting more than 3 pages. Okay, it's taking time. Okay, the answer is default answer for step 1 default route learned via OSPF. Okay, that's answer. The question is this one. How the router receive default information? Okay, default route. I'll put the question also here so that easy for you to understand. Okay, this one question. paste this one. Okay, how I think that they disabled that copy. How did router R1 receive the default route? Okay, how did I type I? How did R1 receive default route? Okay, that's what the question, right? Done. Now, how from which router did R1 receive the default? Okay, from which router via 172.16.3.2? Okay, that is 172.16.3.2 is R2S00. So R1 got the route from R2. Okay, before that I will just turn on this reference. Always port label comes up. Okay, so through this one S00 R1 receive the default route from R2. The answer for this one is next answer is I'm not going to type the question because it takes a lot of time. So R2. You are also busy, so I will just type the answer R2. Okay. Then third question is what's the next question? How can you filter the output of show IP route to show only routes learned through OSPF? Okay, because we have so many routes now. C, L, O, O star ET. I want to get details about only OSPF route. So what I will do, I will just type show IP OSPF. Sorry, show IP route OSPF. Okay, okay, show IP route OSPF. This is one method. You can see only O and O star. Okay. Another one method is show IP route, then pipe operator is above the enter key or below the backspace. Pipe operator include O include. So from the routing table, I take that full input and give to pipe operator. Then from there I have include O. That means I will choose only the routes which has O. Whatever start with O will be displayed. That's the first third question. Okay, so this one I will put this answer in the word file. Okay, here third one. I think you cannot paste anything. Okay, you understood. No, the answer is show IP. Either you can put show IP route OSPF or show IP route, then pipe operator include over. I think better you can use show IP route OSPF. Okay, that is done. Now go for next step or next B. Execute show IP OSPF neighbor command on R1. Okay, so R1 I am going to type another command. I want to see the neighbor details. Okay, show IP OSPF neighbor. Okay, how many neighbors? 1, 2. Okay, 3.3.3. It is full adjust. Okay, full adjacency is there. It's IP address there. 2.2.2. Another one. It's full adjacency. IP also there. So one neighbor R2, one neighbor R3. Okay, this one is R3. Now, which routers are formed adjacency? You can see that R2, R3. Now we know that R2, R3. See, 3.3.3 is the router ID of which one? R3. Okay, and true, you can connect that via serial 001. Okay, this is serial 001. The IP for 001. See, check that 10 dot R2, this is R1, right? So serial 01, 10.5, this one, this is 10.6 here. So this is R3. Okay. Next one is 2.2.2 is R2. How, Mr. You can tell me because 000 connected 172.16.3.2. So from R1 serial 00 3.1 here 3.2 is R2. So R2 is 222 ID, R3 is 3. They are the neighbors and this full adjacent. Okay. What is the next question? Which routers formed R1? What are the router IDs and state of the router ID? I told you 2.2.2 is router ID and the state is full. Okay. But we say that full neighbor, right? Full adjacency. Okay. All of the adjacent routers are shown. Yes, adjacent routers means connected. Okay, R2, R3. R4 not adjacent because one thing it is not connected and it is far away. So this is not only two routers are there for adjacent neighbors, R2 and R3. That's that. Okay. Now, so we already discussed no which routers from we can just go through that video. Okay. Then verify OSP. No, before that command prompt on PC1, ping the IP address of ISP router, then check successful or not. Okay. Go to PC1, IP address of ISP router is. Let me check that IP address of ISP router. It's 64 dot 100 then sorry 64 dot 100 dot 54.5 this one. Okay, so 54.5 54.5. Let me check its pinging. I tried one pinging. Let me check again for you because first time it will fail then it will come. Okay, so that is done. If it's not done, what you can do is reset one. You can clear the OSP process. Need repeat. Okay, it's done. So I need to repeat that one. Okay. Then Mr. Why Mr. First ping always like that first ping always no it will take some time to ping no so first will be failing remaining will come now next time when I do all the four packets will come reply will come four times okay now step 2 verify OSPF V2 operation R2 so what should I do now go to R2 saying the username password is there branch admin is username uh, branch branch admin password is branch 1234 branch 1234 okay now they want to check the routes okay so R2 so show IP route show IP sorry IP route okay here how did the router R2 learn default route ISP okay so ISP okay see default route okay it is statically done okay so we have static configuration okay learn default route ISP statically configured and it is given directly here okay statically they have configured the answer is statically configured okay now next one show IP OSPF interface G0 bar 0 and R2 I'll go to R2 again show IP OSPF sorry so IP OSPF interface G0 bar 0 and R2 and what I am asking is what type of OSPF network is attached to this interface where is this G0 bar 0 this one G0 bar 0 towards PC2 okay what type of network OSPF network see network type is broadcast okay and are OSPF hello packets being sent out this interface no hello because passive interface see that OSPF hello all those packets no they will be sent only between routers no need to send that to PC that's why they disable that interface to not accept hello because otherwise they will also come to participate in that election no that's why they should be configured that interface should not be allowed to accept hello packet that's why we make a passive interface no hello will be received okay using command prompt on PC2 ping S00 address on R3 is it successful okay what is S001 from which PC2 what is it again R3 S001 okay R3 S001 is 192.162.10.6 okay from PC3 ping 192.168.10.6 it's pinging okay so from here you can ping to 001 this one okay after that what's next that is done successful okay now part 2 add new no I think I did up to step 2 okay now go for R3 execute show IP protocol command on R3 so I want to see the which protocol routing protocol configured on R3 okay so that show IP protocol okay so here I want to see what is the protocol I configured OSPF10 okay process ID 10 OSPF is the protocol name then router R3 execute okay router R3 is routing for which network what are the routing networks okay network they are routing so 1.0 10.4 then 10.8 so these are the three networks for which routing is being configured okay OSP routing configured for R3 okay then show IP OSPF neighbor details so I want to say the neighbors of R3 so show IP OSPF neighbor detail here what is the neighbor priority shown for OSPF neighbor routers okay so the neighbor first one 111 and the neighbor priority 0 DR is 00 BDR 000 then this one neighbor 2.2.2 priority 0 DR. This one, that 0 means these routers they never want to be the DR or BDR. Okay, as they are connected serial, they will be there is no election here. Okay, so nobody want to become DR or BDR. That's why they put like this. Okay, so they will be there will be no election, no DR, BR. That's why priority 0. That router will not be eligible for becoming DR, participate in DR election. Okay, that designate router, you know that, and backup designate router. Okay, we'll continue. So the priority is being discussed. Okay, so after that, using command prompt on PC3, ping the IP address of ISP router. Okay, so go to PC3, ping to ISP router. No, ISP router. So there is ISP router 64.100 or 54.5. It's pinging. That's done. Okay. After that, so we check the status of all the OSPF network. Okay. Now, what we to do? Add the new branch office LAN to OSPF network. Okay. So what I will do, I will connect the. Okay. Before that, I have to verify the OSPv2 in R4. Okay. Go to R4. So what's the command? They have. You're taking a lot of time. Okay. Now enable. So what was the command they told? Show run, then pipe operator. The output of show run will be given to input of begin router OSPF. That's why pipe outer. Okay, pipe operator means output of one command given as input of the command. Okay, so I begin router OSPF command. Okay, verify that which statements are present on network that are configured on router. Okay, so they have network 1.0 and 1.11.0. Okay, that been done. Which interface is configured? Do not send OSPF updates. Okay, see here, passive interface D001. That means this interface is passive. That means they will not send OSPF update packets. Okay, now connect the branch office router R4 to OSPF network. You know that passive interface means they will not participate, okay, in OSPF updates. Now connect branch office router R4 to OSPF V2. So what I will do using Ethernet cable, connect G0 bar 0 and router R4 to G0 bar 1 of switch 3. So take Ethernet cable, make it fast, mister. We have no time. We can do. So G0 bar, okay, from here. G0 bar 0 to S4 G0 bar 1. Done. Just make it fast forward. Okay. Now show IP OSPF neighbor command to verify R5 is adjacent with R3. Okay. So go for R4. The command show IP OSPF neighbor. So R3 is a neighbor and that's 333 means router ID of R3. Okay. Then full, here we have full DR. Okay. See, other one we have command. So what state is displayed? Okay, it is full, but it has slash dr. So now I'll go for show IPS OSPF neighbor of R3. Let me check R3. Okay, the same command show IP OSPF neighbor on R3. You can see 4 is BDR, full BDR, and remaining one means R1, 2 means R2. It has 3 neighbors, right? 1, 2, 4. 4 is the full BDR. This is full BDR. This is for R4. This is DR. Okay, that means here now I am connecting two routers in a Ethernet. So in that case, one should be designated router, other one should be backup designated router. But in serial, we didn't configure anything. Okay, there's no election. But here in the Ethernet network, if you're connecting two routers, now one should be selected as DR, designated router, other will be selected as BDR. Okay, once it is down, this will become DR. That's backup. Okay, that's answer question here. Why is the state of R4 different that of R1, R2? Because R1, R2 are connected, R3 are connected in the serial network. There is no election happening there. No DR, no BDR. But here, R4, R3 are connected in the Ethernet network, and there is a election happening, and this will become DR. Other one will become BDR. Okay, using the command prompt on laptop, ping the address of PC2. So laptop, I will type the IP address of PC2, right? So desktop command prompt, PC2. PC2 is what is the PC2? 17.6.2.2. So ping 172.16.2.2. Asking it is pinging or not, right? Is it successful? Let me go for fast Euro. Maybe it will come. Yes, it's pinging. So this network is now this part of the whole network. Okay, that's what. Okay. So only thing the confused answer is this one, right? Why is the state of R4 different from that of R1 R2? Okay. So as I told you, this R1 R2 R3 are part of serial network, so there is no election happening that the priority was also zero. But here R3 and R4 part of Ethernet network, so one should Ethernet means one should be designated router DR, another one should be BDR. That's why that different state OSPF neighbor command we are having R4 is different from R1 R2. Okay, hope you understood the activity. Okay, watch this video and do yourself. Okay, and also that button I told you, another right.